Okay, okay. But I can see only 12 participants. बाकी लोग अभी ज्वाइन करेंगे. Should we wait for 3-4 minutes? Okay, so maybe you may start the session at 7-8. Let's wait for 4 more minutes. Okay, all right. Yeah, so very good evening.
Good evening, sir.
Good evening, sir.
Good evening, Rajat. Good evening,
Good evening,
Victor.
sir.
Good evening, sir.
Good evening, Niranjan. So we are 19 now. So yesterday we had some overview of Python programming, some of the basic, overview of some of the basic programming constructs. We talked about 7 basic data types available in Python, including numbers, and then lists, tuples, dictionaries, sets. So we talked about these basic, data types. Then we talked about conditional statements, if, else if, elif, and we talked about loops, and we were discussing about functions. So from functions, we'll be moving directly towards some hands-on, uh, like how to train a classification model, what machine learning is, and how to practically implement it. Right?
Okay, sir.
So let me share this screen. Can you see the screen?
Yes, sir.
Okay, let me just share. All right. So we discussed that how you can execute your program directly from Google Colab. But if you need to have, some software installed on your local machine, you can do that. But for just starting, it is not required. You can do most of the stuff online if you have just Gmail account and you have access to Drive. So we created one folder uh, here, and yeah, the folder was Abonix. Yeah, it was somewhere in the Abonix. Yes, Abonix internship, and we created this Google Colab where we implemented some of the concepts. We talked about some of the data types, conditional statements, loops. Start with function, like what a function is, so that the people who are just newbie to this Python programming can understand that what a function is, and these are very, very useful and extensively used uh, parts of Python programming. So you can define a function with this keyword def, and you can define a function like this, and you need to place colon, and whatever code you want to write, that should be indented inside this def block. Like I'm writing a simple function f to print hello. And this is the definition of function. You can define some other function. Like this is a simple function that will calculate whether uh, a number is even or odd. Or let's calculate the factorial of a number. So just you need to pass value n, and factorial is just the multiplication, cumulative multiplication of the number. Like you need to find out the factorial of 5, so it will be 5 into 4 into 3 into 2 into 1. So starting from 1, you need to multiply it, and let's get this is stored inside a variable fact, and we need to initialize it to 1 as well, and then we will run through a loop for okay, we have declared here for I in range one to n plus 1, because it ends at 1, and then factorial equals to factorial into I, and whatever value you have here, you can return that, right? So these are two functions, and how we can call functions, we can just place the name of the function and we can call it. If it is returning some value, then we can print it or we can store it somewhere. But if it is not returning any value, then we can just put the name of function, and it's enough. So let's execute this. It is starting. And let's see the output that it is showing you. Hello, and you can call it any times. If you call it one more time, so you will get hello two more times. And you can call next function, which is f1, but it will return some value. That's why either you need to store it in some variable or you can directly print it. And you need to pass some value here. Factorial of 5 is x. And here you can see that output is 120. Right? So this is about functions, and the functions are very interesting and very useful programming constructs in Python. You can even pass variable number of arguments in a function. You can have nested functions. That are some special attributes of Python. So this is all about basics of Python to get you started with like what a programming language like Python is, what are the different programming constructs, how to work with it. And now let's jump to data science or machine learning, that how we can implement machine learning, how we can train some classifiers, how we can solve some problems. So today we are going to consider a very basic example in machine learning, and before that I'll be talking about some of the libraries which are very helpful in data science, like pandas. There are some libraries for visualization, for creating graphs and charts and bars. So there is matplotlib, seaborn. So we'll be talking about a little bit you know so some of the hands-on aspects of these libraries. So let me find out some data set. So we'll be working on this data set, which is iris data.csv, and CSV stands for comma separated values. So it is pretty much like an Excel sheet, and some data is placed inside this file, right? So it does not have any header. So we'll be inserting header to this, and there are 5 columns. You can see the column A, B, C, D, and there are some values placed inside this data. Are you able to see this data set? Yes. Were you able to see the data set?
Yes, sir.
Right. Okay, so we'll be working on this data
Yes,
set,
sir.
and we'll be training one machine learning classifier using this data set. And this data set is basically the measurement of iris flowers. So what are the iris flowers? Those are just flowers of like this. They have various varieties. Like this is a typical iris flower, and there are different varieties of this. And we have measurement of 150 iris flowers, and there are 3 varieties or 3 classes of iris flowers. So one is iris setosa, and another is iris versicolor. So there are some records from this particular class, and there is another category which is iris virginica. And there are 4 attributes that have been recorded for these 150 samples. And the first attribute that we have recorded is petal length. Second one is petal width, and the first one is sepal length, sepal width, petal length, and petal width. So these 4 attributes have been recorded, and based on that, there is a class label. So we will train a classifier that if we just provide these 4 attributes, so we will train a system so that it can guess the class label based on these features. And that is the basic idea of machine learning. So let's just upload this particular file to our folder that we have created inside our drive. And this is iris.csv. Okay, let's get back to Abonix. Right. So this is our data set with us. Let's create a separate, fresh, new Colab file. Let's close it. And let's name it second session. Right. So today we'll be talking about that how to use different libraries. So there are different libraries in Python that make your work or kind of exploration very easy. Right. So we'll be importing some of the libraries like pandas, which is used for data analytics, and it is very core package of data science, and we are renaming it as PD. We'll be importing another package, NumPy, which is for numerical computation, as NP. And for some visualization, we'll be importing a package called as Matplotlib. So what is a package? Do you understand what a package is? Right. So these are some of the packages that we'll be using today. And first of all, we have this data set available. So we would read this data set, and we'll do some of the kind of analytics on this particular data set, like what this data set is all about. What are some of the statistical properties of this data set, how to create some of the visualization around this data set. So we'll be doing all that stuff. And we have imported this, these packages. So these are very essential packages. We'll be importing some more packages for doing, some more stuff. Let's execute this. So first thing is that we need to read this data set, which is available, pyplot as PLT. Okay, so instead of from, राइट तो सबसे पहले हमको अपनी एक फाइल को रीड करना है, और फाइल को रीड करने के लिए हमको क्या है कि जो हमारी ड्राइव है उसको माउंट करना पड़ेगा. तो देयर इज अ पैकेज कॉल्ड एज google.colab import drive. and then we just need to write it drive dot mount, and it needs to be mounted at the root point, which is content slash drive. Right, इस कोड को एग्जीक्यूट करेंगे तो we will have to provide permission so that this Colab can access the drive. Just click here, allow. So this drive will be mounted, and now we can read and write data, and we can access our drive. So we have mounted our drive. Now we have our data available, and for reading data we'll be using this particular libraries pandas that we have renamed as PD for simplicity. So we'll be storing our entire file in a variable, and from here you can sense that how powerful Python is, that you can read your entire file, your big data inside just a variable. And there is a function inside this pandas library which is read underscore CSV, and just you need to provide the path of the file. So the path of the file will be content slash drive slash my drive, and your path to this particular folder. So it is inside my drive and then Abonix internship. एंड देन उसके बाद हमको जाना है इस फाइल का जिसमें हमारा डेटा है iris data.csv, इसका नाम हमको प्रोवाइड करना है. Once it is done, let's execute this file, and now your entire data set is available here in this file. But before that, क्योंकि अभी आपने फाइल देखी थी तो उसमें the headers were missing. So let's define the headers as well so that it becomes easy to read the data. So we are creating a list which will be having these attributes: sample length, and then sample width, and then petal length. So these are the 4 attributes जिस पे we have collected data. And last column represents the class label. It is 4 attributes that you have collected for your for 3 varieties of the iris flower. So to which particular class they belong. The last column is the class, and we can specify here an attribute called as names, and we are passing it as value n. Okay, we need to execute this code first so that it can recognize it. So now you have read this entire data set, and that is available in a variable which is of type data frame. तो अब आपको देखना है कि इसके अंदर जो डेटा आया, what that data is. So you can just write here the name of the variable, just execute it, and you will see that data set looks like this. But since there are many rows, so it has just shown the starting 5 rows and ending 5 rows. And here you can see that the data set looks like this, and it has added these headers to the data set, right? So there are different functions that you can call on this data set. Like if you just want to take 5 starting rows, so there is a function called as head. So by default it gives you 5 starting rows, But if you want to get starting, suppose 7 rows, so you can pass some value here and you'll get 5 rows. And similarly, there is another function called as tail. Tail will give you ending 5 samples or as many samples as you want. Suppose you are interested in seeing the last 3 samples from the data, then you can get it. There is another method to randomly select the data, and that is called sample. So you can sample randomly, so it is selected 75th, 48, and 102. So these are the samples from the data set, right? If you want to get some other information like how many fields are there, whether there are some missing values or something like that, so there is a function called as info that you can call, and it will provide you a snapshot of your data set. So it is giving you information. It is telling that how many values are there corresponding to each column. So there are 150 values corresponding to sepal length, sepal width, and it is also showing you that what type of values are these. So these 4 values, the feature columns are of type float, and this is of type distinct. That's why it is it is mentioned here that it is an object of class string. And if you want to get some statistical information about this data set, so there is another function called as describe. So you have these count for all these attributes, but the values or the description will be available only for the numerical columns. Right? So there are the last column, which is of class, is containing textual information, and these 4 columns are numerical. That's why you will take like how many numbers are there corresponding to each of the column, and what is the mean, what is the standard deviation, what is the minimum value, and these 4 quartiles or percentile of the data and their corresponding values. Like 25% of the values for sepal length lie between this range 5.1, and these are the different other percentiles of the data. So this is very easy and very powerful to describe the data. And if you want to see that how many classes are there corresponding to how many samples are there corresponding to each class, then there is a function called as value counts. And if you want to suppose index just a particular column, so you can refer a particular column with a function called as LOC, and you can specify here the name of the column. And suppose I just want to print column class. Okay. Let's use ilog function, which will give you some numerical representation like which rows and which columns you want. So I want all the rows, and I'm interested in just last 2 columns or the first 2 columns. 0 and 1 and 2 will be Just take note. So here you can print it like this, sample length and sample width, right? So the next thing is that how we can apply machine learning on it. You can have some visualization on this data, and there are these two libraries available, like matplotlib and seaborn. So you can have some visualization for the data, like you just want to print the distribution or some bar plots between two values, or just the counting of different numbers. So you can plot different sort of charts, graphs. So these are the different types of plots available. Like there is bar plot, box plot, categorical cat plot, and you should refer to these two libraries, which are matplotlib and seaborn. So they have their dedicated websites, and you can read a little bit about different types of plots available. There is getting started examples available. Like you just want to print just a line like this. So you should have x and y's corresponding to it. So there is some linear spacing corresponding to this. So there will be 200 linear samples, and corresponding to that you'll be printing so there will be a range of 0 to 200, and you'll be printing some samples out of that. And you can use matplotlib for kind of plotting this sort of charts. You just need to copy it, and you can paste it like this, and once you execute this, you will see the plotting. So it is just a simple line, and there are different types of plots available. Like it is just a line plot, and there are different examples available. There is some cheat sheet available as well, some very, like this is a scatter plot, this is bar chart, this is step plot. So refer it, and like you can use this just plot function, and you can specify what type of plot you want. Or if you are interested in plotting a bar chart, so you can use it. So in bar chart, we have these bars and their corresponding values, and there are histograms and different other types of plots. So matplotlib is a very useful visualization library, and there is some advanced libraries as well. There are some advanced libraries as well, like seaborn. So you can also refer it, which will give you even better plots. And there is tutorial available for this, like what type of plots you want. So you can really make some sophisticated plots with the help of these two libraries, seaborn and matplotlib. And yeah, so we have these four variables: sepal length, sepal width, petal width, uh, uh, based on which we'll be training one machine learning model, and we'll be predicting that the class of the model. So now let's understand that what machine learning is and how does it practically work. So let me just create one section here. So for machine learning, There are different libraries available, but today we'll be using one library called as sklearn, which is scikit-learn. So you can import this library sklearn. So this particular library has all the tools that you need to, do some coding to create some system which uses machine learning. So we have imported this library, and we'll be splitting our data set in training and test parts. So for that, from sklearn, so there is a sub package called as model selection. Import, train, test, split. We'll be using this to divide our data set into two parts, training and testing. And then we'll be using some of the algorithms from machine learning. So there are different algorithms from machine learning. Yeah, can anyone tell some names of the machine learning algorithms?
Logistic regression, random forest, decision trees.
Yeah, so there is logistic regression, there is decision trees, there is knife-based classifier, there is KNN. If we talk about the supervised learning, there is support vector machine. So there are many algorithms available. There is XGBoost, there is CatBoost, there is random forest. So there are many algorithms available that you can test. So today we'll be talking about some of the basic algorithms. So for example, let's take into consideration decision tree. So decision tree is available in a sub package called as tree, and we need to import it from there. In the same way, if we talk about logistic regression, it is available in linear model. Logistic regression. And if we talk about support vector machine, then it comes from a package called as SVM, and the name of the class is SVC. If we talk about KNN, then it is available in neighbors package, and linear discriminant analysis LDA is also there. So there are many algorithms available as part of this sklearn. So let's understand that how to split our data, how to train a model, how to do some sort of transformation. We need to convert this pandas data frame into some NumPy array, and we'll be splitting it later on. So let's import these packages, and once we do this, so this is for training and testing split. These are our algorithms, and once we create algorithms, then we need to kind of test their performance, and there will be some performance metrics. So from sklearn dot matrix, we can import accuracy score, we can import classification report, and we can import confusion matrix. And there are many other performance metrics available, like you can use ROC, AUC scores. If you're working on regression problem, then you can measure the mean squared error, right? So I think this is the bare minimum that you need for training or for creating a machine learning model. So let's just execute this piece of code. And then here we will split our data set into training and testing. So we'll be using this particular function, which is very, very important. And it returns 4 values. So the beauty of Python is that functions can return multiple values, which is not possible in other programming languages. And you just need to specify your X, which are the features, and Y's, which are the class labels. And before that, let's just convert our data frame into NumPy array. So df.values attribute will do that, so that it will be simple for you to kind of split your data. So we'll be keeping features here and class labels here. Right, so we just need to use array indexing and array slicing here. So X should contain starting 4 columns. So the syntax will be like it should contain all the rows, but it should contain column starting from 0 to 4. So it will include the column 0, 1, 2, and 3, because indexing starts from 0 and it excludes the last column. And similarly, Y will contain all the class labels. So it should contain all the rows and it should just contain the last column. If you do that, okay, and we need to specify data here. So you have basically divided your data set into 2 parts: the features, which are the numerical values, and their corresponding class levels. Right, so now you can split it further into training and testing. So training data is used for training your system, for teaching your system that these 3 classes look like this. And testing will be used to test that how well it had learned from the data. And for that, we can pass here just X and Y. And we can specify here that in what ratio we want to keep our training and testing data. So there are 2 variables available here. So either you can specify the test size or you can specify the train size. If you specify one, then other one will automatically get inferred. Like if you want to keep 30% of the data for testing, so you can specify here 0.3, and you want to make these results kind of reproducible, so you can specify random state, and you can seed it to 45 so that your results are reproducible. Otherwise, these will be stochastic or random. And it will return 4 values. So this function will return 4 values. It will split your X and Y's into 4 values. So X train, X test, Y train, and Y test. These are just the names of the variables. You can keep it anything. So you have split it into, these 4 parts: X train, Y train, X test, and Y test. So you'll be using X underscore train for and Y underscore train for, training the model. And let's create some model. So what is model? Model is just an instance or just a variable of type any algorithm, like जिस भी type का आपको classifier train करना है. So let's talk about logistic regression. So there is linear regression, which is used for regression, but logistic regression can be used as a classifier. So let's consider it and let's create a model. So model is just the name of a variable. You can keep it anything. And you're instantiating this logistic regression. And there are different hyperparameters that you can pass here. And you can read about it, that how logistic regression works. Let's keep it blank. Let's go with the default values. So it will instantiate logistic regression. And now you can fit this model model.fit, and here you need to pass the training set. So that is inside xtrain and y_train, right? So once you do that, the model will learn from the examples that it is seeing from x_train and y_train, and it has instantiated this logistic regression class, and it has fit this model. So since our data set is containing only just 150 records, that's why it's just completing its training in a moment, maybe a few seconds. But if you are having very large data set, you can maybe thousands of or millions or billions of records, and it may take proportionate time based on the size of the data. So the training is finished, and now let's check that how well it is performed. So for testing, we have our test data set, which is available in this. The samples are available in x_test, the features, and class labels are y_test. So this is just a question paper. So these are the questions, and these are the answer keys. So we will take the test of the model, and we will see that what are the responses coming from the model. So we'll store those predictions in this variable predictions, and we can use this model dot predict, and questions are available in this x_test. So these are just the 4 attributes: sepal length, sepal width, petal length, petal width, and we will ask the model to return the corresponding class labels, and class labels will be returned here, and we will just compare it, that what responses model has returned and what are the actual responses. So actual responses are available in this y_test, and we'll be checking against those. So the predictions are there. Now we can test the model, that how accurately it performed. So let's talk about some of the performance metrics. Metrics means performance parameters, and let's print the accuracy score. So print accuracy of logistic regression is, so you can call a function called as accuracy score, and you need to pass here 2 values, like what are the predictions and what are the actual values. Right, so it will return some value between 0 and 1. So here you can see that its accuracy is 95.5%. And if you want to see it in the form of percent, so you need to multiply it with 100 and need to place a sign of percent, and that's it. So here you can see that logistic regression performed 95.55% accurately, and you can test other methods that whether they are equally good or they are not that good. So for changing just a model, either you can create another variables, model 1, model 2, model 3, and then compare it. But if you just want to change it, the model type, so you need to just comment it and just copy it, paste it, and let's evaluate support vector classifier SVC. Just execute it. Prediction, so everything all over again, but you will get a different accuracy, and that is 93.33%. So in this way, you can just check different methods you can evaluate on your data set. And if you just want to see that where this particular model is committing mistakes, like it is giving you 93.33% accuracy, that's pretty much acceptable. But if you just want to see that where this 6 point maybe 7% how this error is occurring, so you can just figure it out with the help of another performance metric, and that is called confusion matrix. And let's print confusion matrix. You just need to pass these two values here, predictions and y-test. And it will print the confusion matrix, which is just a kind of a square matrix. And if there are 3 classes, so it will be a 3 by 3 matrix. And if there are n classes, so it will be of n by n. So here you can see that there were 17 instances. So total, we used 30% of the data for testing. So there were total, 150 samples, out of which we used 30% samples for testing and 70% data was used for training. So 30% of 150 was 45, rows that we kept for testing our model, and rest of the, 105 rows we kept for training. And it will be a square matrix of n by n. So this is class 1, class 2, and class 3, and again in the columns class 1, class 2, and class 3. So here you can see that there were 17 instances of class 1, and all the instances are correctly classified. And for class 2, there were total 16 samples belonging to class 2 that we used for testing. But out of which only 13 samples were classified correctly and 3 samples were misclassified in class 3. So you can see that error has occurred at this place. So there were 3 instances of class 2 that were misclassified in class 3, and that's why its accuracy is coming as 93.33%. Right? Any questions so far? Does it make sense?
Yes, sir.
Okay. Right. And if you want to actually, see like how to make predictions. So अभी हम इसको देखेंगे कि इसके basis पे how you can use this model. Maybe you have trained a model and you may create some intelligent application around that, maybe some web application or some mobile application where the user just need to enter these 4 values like the sepal length, sepal width, petal length, and petal width, and based on that you will get the prediction. So you can use that, and maybe you have some HTML form that you have created, some user interface. The user is just filling up those values, and at the back end there is a model, machine learning model, that is giving you predictions. So if you just want to test it in that way, like you have these, some 4 values: petal length, petal width, sepal length, and sepal width, like this. And you just want to see that to which particular class these values belong. Right? So these are the 4 values, and you want to see the prediction for this. So you need to just keep it inside some NumPy array of 2-dimensional. And just need to keep comma. This is some data for which you want to see the predictions. You can just call the function model dot predict and end. So this is iris setosa. So maybe we took this sample from here, and you can see that it is belonging to iris setosa only. Right? So this particular model can be used at the back end of your maybe some mobile app, some website, or some desktop application where these predictions can be made. Right? And there are many use cases around that, like uh, you are on Amazon, and based on your behavior, the Amazon can predict that what other items you may like or you may add to your cart, or based on your behavior on a particular website, now like how much time you are staying there, what is your behavior. So there may be some predictive analytics, and the machine learning can be very, very useful uh, from that point of view. And once you train your system, you can save your model, you can export it to some drive, so you need not train the model again and again. You can use it anytime, whenever you want. And there are some libraries for doing this, like there is library called as pickle, there is a library called as joblib. So let's import another library, job lib. And inside joblib there is a function called as save model. Okay. Let's see that what's the name of. So we can call a function job lib. Yeah, so there is a function called as dump, and there is a function called as load. So these two functions you can kind of use. So first one is the name of the model and the corresponding file name. So it is saved with extension .sav. So what is your model? Model is in variable model, and my model .sav. So maybe you need to provide the entire path for your directory, which is like this. And here you can check whether the model is exported or not. Maybe you need to refresh it. Okay, what happened? Yeah, model is there. So this is mymodel.sab. And next time, if you want to use it, then you can just directly load this model into some other variable, maybe model 1. And then there is correspondingly function called as model joblib.load. And you can load it from its name, my model.sab. Okay, so you need to provide the entire path. Again, so the model 1 has been loaded and you can directly use it. Like model 1 dot predict, and you just need to pass the value of fan. And again, you can see that it is predicting well. So in a nutshell, I have told you about what machine learning is, what are the different things जो कि जनरली बच्चा पूरे सेमेस्टर में सीखता है, that you have learned in this 1 hour. यानी any questions? Yes, are people there?
Yes, sir. No questions, sir.
No, sir.
Okay, no questions. Right. So let me share a link for this particular work that we have done today. You may download it and may practice it.
Okay, sir.
So these are available here. Maybe आपको इसको थोड़ा rename करना पड़े. Just remove copy. Yes, I'll share it. Share it. Link. Okay, you download it, and maybe after class 1, means maybe after next class, I'll be giving you some assignment just based on the things that we have done. So you'll be working on a different data set, and you'll be doing the same stuff, the same steps, and you'll be making your submissions. Right?
Okay, sir.
So that's it for this session, and bye-bye.
Thank you, sir. Good night.
Good night.
Yes.
Yes, sir.
Yes, sir. Of course, sir.
No, sir.
No, sir.
Sure, sir.